The small shop owner has bought in the Santa or in any right bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types.
Up, down, right, left.
I am not inferior to anyone.
We are Clarus. You are top on the Everest. Congratulations.
I want to be a leader.
Hi friends, how are you? This is Girija of 9th standard from TSWREIS Jadcherla, Mahabubnagar district. Okay friends, today I am here to teach you a lesson which is very important to us and which we can study in higher classes also. Okay friends, are you ready to guess the title of this lesson? Okay, observe me what I am doing. What I am doing? Yes, you are right. I am walking. And see here what I am doing to this object. What I am doing to this object? Yes, you are correct. I am moving to this object. It means in physical science we have one particular word which describes this movement. What is that word? Do you know? Yes, you are right. The word is motion. What is that word? The word is motion. The word is motion. Okay friends, see here. Why this object fell down? Yes, because of gravitational force. How do we know that the earth has gravitational force? Which the scientist told us? Yes, Newton told us that earth has a gravitational force. That's why whatever we throw into the sky will fall onto the ground. Okay, Sir Isaac Newton proposed the laws of gravitation and also laws of motion. Today in this class I am going to teach you the lesson laws of motion. The lesson is laws of motion. Laws of motion. Okay friends, do you know how many types of laws are there? Okay, let's discuss in this class. Okay, once see the slide. Today we are going to discuss the lesson laws of motion. See the slide friends here. And do you know who is he? He is a Sir Isaac Newton. And Sir Isaac Newton proposed his 3 laws of motion to explain the connection between the force and motion. And Sir Isaac Newton was born on 25th December on Christmas Day in the year of 1642. And his parents are Isaac Newton and Hannah Azykoff. And friends, okay, there are 3 types of laws. Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. And these 3 laws are popularly known as Newton's laws of motion. Okay friends, now let's see a historical story of Newton's laws. See the slide once. Daily Newton's used to roam in the forest. One day he went to the forest and sat under an apple tree. Then suddenly an apple fell from the tree onto the ground in front of him. Then Newton saw that apple and he was thinking that why this apple fell onto the ground, why doesn't it go up? He was thinking about that, and finally he proposed the laws of gravitation and also laws of motion. Just now I have told you 3 laws of motion are popularly known as Newton's laws of motion, Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Okay friends, now first let's discuss about Newton's first law of motion. Newton's first law of motion, it explains that what happened to an object when no net force act on it. See here, see the object here, what is this? What is this? Yes, this is a car. Now the car is in rest position. Yes or no? It means here the net force is not acting. Here the net force is 0. When we apply some force to this, then it comes into the motion. Yes or no? Yes, here Newton's first law explains that what happened to an object when no net force act on it. Okay friends, And the Newton's first law of motion explains that a body, see on the slide, a body continues its state of rest or of uniform motion unless a net force acts on it. It means it continues the state of rest and state of uniform motion unless some force act on it. Okay, did you get my point, friends? Okay, this is about Newton's first law of motion. And do you know the other name of Newton's first law of motion? Okay, let's know here. The other name of Newton's first law of motion is law of inertia. What is the other name of Newton's first law of motion? Law of inertia. Law of inertia. The other name of Newton's first law of motion is law of inertia. Do you know what is meant by inertia? Okay, let's see on the slide. Okay, friends, inertia. Okay, see here, inertia is nothing but the natural tendency of an object to resist a change in the state of motion or of uniform motion unless a force acts on it. For example, the rest object, see here, what is this? This is a duster. Here it is in rest position. It means it continues the state of rest until some force acts on it. For example, now I am applying some force to it, then it coming into the movement. Yes or no? Yes. If I not apply force on it, then what happens? It continues the state of rest position. Okay, friends, this is about Newton's first law of motion. And see the slide here. There are some examples of Newton's first law of motion: a moving car, and batsman, pumpkin, ball, and there are so many examples. Newton's first law of motion is also known as law of inertia. Inertia is nothing but the natural tendency of an object to resist a change in their state of rest or of uniform motion. Okay, friends, see here. Do you know how many types of inertias are there? Okay, let me tell you. There are two types of inertias. They are, the first one is static inertia. The first one is static inertia and the second one is dynamic inertia. Dynamic inertia. Okay, first let's discuss about static inertia. See on the slide, static inertia is nothing but the body at rest always tries to stay at the same state of rest. It does not accept any change in its position. This property is known as static inertia. For example, see here, see the carom coins, friends. Daily in the evening, our swearers use it to play carom board. Yes or no? Yes. It is also a very interesting game. So, I placed the carom coins in a vertical stack, and by applying some force to the striker, I am hitting the striker by applying some force. Then observe what happened. When the force acted on the coins, then the coins fall down, and the remaining coins in the stack are at rest position. It means they are not accepting any change. Okay, did you get my point, friends? And see here, another example, stack of books. How many books are there? Count. 1, 2, 3, 4. There are 4 books. And see here, now by applying some force, I am pulling one book, I am lifting one book from the stack. Then what happened? The book which I removed from the stack is only in the moment. The remaining books in the stack are at rest position. They are not accepting any change in their position. Yes or no? Yes. These two concepts are explained by the static inertia. These two concepts are explained by the static inertia. Now, okay, friends, now let us go to the dynamic inertia. Dynamic inertia is nothing but the body which is in motion always tries to move in the same direction until some force acts on it. For example, see here, what is this? Yeah, this is a bicycle. Now, it is in the movement. It is in the movement. Here, it continues its state of motion until some force acts on it. When some force acts on it, then it comes into the rest position. Okay, did you get my point, friends? And for example, ball. When we throw the ball somewhere, what happens? The ball moves in the same direction until some force acts on it. And see the, for example, in this slide, they are playing the football here. So, what are you observing there? They are playing football. The ball is at rest position. When the player applied some force to the ball, then the ball came into the motion. The ball come into the motion and it moves in the same direction until some force act on it. Until some gravitational force act on it, it moves in the same direction and finally it comes into the rest position. It means here, see, the static inertia does not accept any change in their position, it continues the rest. Yes or no? But dynamic inertia, it continues the movement. It continues the movement. It does not take rest. It continues, it moves in the same direction. Okay, friends? Now, I think you have clear idea about the static inertia and dynamic inertia. Okay. Now, let's go to the, now let's see a video. This video is about, okay friends, let's assume that we are, we went for Christmas holidays and we are coming back to the school. When we are coming back to the school, then what happened? We are traveling in a train or any vehicle. Then, when we are traveling in any vehicle, then what happened? There we observe the inertia. How means, see, by seeing this video we can understand. See here, now we are going to see the video about inertia. When we are coming back to the school or when we are going to a village, then we travel in a train or any other vehicle, then we continues to move forward when it comes to complete stop. Yes or no? See there? Yes. It means here we are experiencing the inertia. Okay friends, inertia is a tendency of a body to resist a change in motion or rest. And when a vehicle stops, we tend to jerk forward before it coming to a complete stop. In the same way, we will jerk backward when the vehicle begins to move. This phenomenon occurs because of the Newton's first law of motion. Newton's first law of motion, an object at rest or motion will continue to be in the same state unless acted upon by an external force. Okay friends, which means here the objects tend to keep on doing what they are doing unless disturbed. This is the video friends. I think you all like this video, and when you go to your village for Christmas holidays, then you observe, you have to experience the inertia, okay? Okay friends, now let us go to the Newton's second law of motion. We have successfully completed the Newton's first law of motion with examples and a video, and now let us go to the Newton's second law of motion. But before going that, we have to know some important words such as acceleration and momentum. What are they? Acceleration and momentum. Momentum. Acceleration, what does it mean? Okay, let me tell you. See, let us assume that this is a motorbike. Okay, friends, let us assume that this is a motorbike. When we are riding, when our brothers or fathers, when they are riding bicycle, then we have two handles. The right handle is the accelerator. Yes or no? When we accelerate more, then the bicycle move very speed. Then the motorbike move very speed. When we accelerate slow, it moves slowly. Yes or no? Yes. If you want to cover a far distance within short time, then we need to accelerate more. It means here the acceleration is depend on the velocity. So, acceleration is nothing but the rate of change of velocity. See on the slide, acceleration is nothing but the rate of change of velocity is called acceleration, and acceleration is denoted as A, and acceleration equal to delta V by delta t. Here delta indicates change, V is the velocity and t is the time. And the SI unit of acceleration is meter per second square. In MKS, in CGS, centimeter per second square. It is a vector quantity. Okay friends, see here, acceleration is denoted as A, and acceleration formula is the rate of change of velocity. It means delta V by delta t. Remember friends, A equal to delta V by delta t, change in velocity by time taken. And next, momentum. Momentum, see here, what are these? These are the two balls. This is a cricket ball and this is a badminton ball. Yes or no? Yes. When I throw this ball towards you, which one hurts you more? Yes, the cricket ball hurts you more, because the cricket ball has more mass than the badminton ball. That's why the cricket ball hurts you more. And next, see here, what is this? Yes, this is a toy gun. When a bullet fired from the gun, it reaches the target and it may be destroy the in front of that bullet. Yes or no? It may be destroy the wall, human being or anything. It has that capacity because of its high speed. Here bullet come with very high speed. It has more velocity. So friends, here the momentum is depend on the mass and velocity of an object. Okay. So the definition of momentum is the product of mass and velocity is called momentum. See here, momentum, see on the slide, the product of mass and velocity is called momentum. Momentum is denoted as P. P equal to mv, it means mass into velocity. SI unit of momentum in MKS system is kg meter per second or Newton per second, and in CGS system grams centimeter per second, and here it is also a vector quantity. Okay friends, see here once, momentum can be denoted as P and the definition of momentum is mv, mass into velocity. You have to remember this too, okay? Okay friends, now let us go to the Newton's second law of motion. Newton's second law of motion, it explains that what happened to an object, see on the slide, what happened to an object when non-zero net force act on it, okay? It means when non-zero net force is acting on it, it means when some force is acting on the object, then what happens is explained by the Newton's second law of motion. See here, see the picture on the slide. What you are seeing here, we are seeing that an elephant and a person. Yes or no? A person was pushing the elephant, but is it possible to push the elephant by applying his force? No, it is not possible because elephant has more mass. And see here, what we are seeing here, here also a person pushing a big red car. Yes or no? But there is no movement in the car. And here in this picture we are observing that a person easily moving the trolley by applying some force. By this pictures we can understand that the objects which has more mass need more force, and the objects which has less mass, there we need not to apply more force. Okay friends, see here, to push this table I need to apply more force because it has more mass, but to move this cycle or the duster I need not to apply more force because it is lighter in weight. Yes or no? Okay. So here Newton's second law tells us that according to the mass of the object we need to apply force. So Newton's second law states that F equal to ma, it means force equal to mass and acceleration. According to the mass we need to apply force, then the objects come into the acceleration. Okay friends, see on the slide again. The rate of change of momentum of an object is proportional to the net force applied on the object in opposite direction of net force. It means here what the objects which are in the momentum, it means see once in the chart, the rate of change of momentum, it means the objects which are in the movement which has more mass, the objects are directly proportional to the net force acting on it. They are proportional to the net force acting on it. It takes in opposite direction of the net force. And we all know that momentum means the product of mass and velocity. The momentum is the product of mass and velocity. So P equal to mv. Okay friends, now let us see the derivation part, how this F equal to ma derived. Let us see how this F equal to ma derived. Okay. I think you understand the acceleration and momentum. Did you remember the formulas? Okay. See here, let us see how this moment F equal to ma derived. First, what is the formula? The rate of change of momentum of a body is directly proportional to the net force. It means here net force can be written as F net, is this is the symbol of directly proportional. So here net force is directly proportional to the change in momentum, Momentum can be written as P. Just now I have told you, no, momentum can be written as P, change in momentum by time taken. So friends, here I am writing this as F net is directly proportional to the change, can be denoted as delta. So change can be denoted as delta, and here P, delta P, it means change in momentum by delta T and time taken. So here F net is directly proportional to the delta P by delta T. We all know that P equal to mv. So here I am writing delta mv by delta T. Okay friends, did you got what P? We know that P equal to mv. So I am writing here, instead of writing P, I am writing mv, mass into velocity, and next F net equal to is proportional to the delta mv by delta t. And friends, here I am removing the proportional. I am removing this proportional and I am inserting the constant k. I am taking constant as k. Okay. So, F net equal to k delta mv by delta t. Okay friends, and see here del F net equal to I am writing this here. I am writing this m forward and delta in the middle and velocity at last and by delta t. To get the formula of acceleration, I am changing this because to get the formula of acceleration, I am changing this. So, observe this delta v by delta t equal to a. It means acceleration equal to the rate of change of velocity is called acceleration. We all know, yes or no? A equal to delta v by delta t. So, I am writing here, instead of writing this delta v by delta t, I am writing F net equal to k into m into a. So, if we take k as 1, then we get F net equal to 1 ma. When we multiply this 1 with ma, then we get F net equal to ma. So, F equal to ma. It means the force equal to the product of mass and acceleration. Force equal to the product of mass and acceleration. Okay friends, did you get this derivation? Okay, let us once see in the slide. The rate of change of momentum is proportional to the net force applied on the object. Thus, net force, it means F net is proportional to change in momentum by time, and here F net is directly proportional to the delta p by delta t. So, delta p is a change in momentum of an object. When the symbol proportional is removed, a constant is inserted in the equation. So, then we get F net equal to k delta p by delta t. If k is a constant, then we know that p equal to mv, and so friends, see here F net equal to k m delta v by delta t. Delta v by delta t is the acceleration a. So, then we get delta. So, F net equal to k m a. If k equal to 1, then F net equal to m a. So, F equal to m a. The units of force is kg meter per second square and newtons in MKS system. Okay friends, this is the derivation, and now let us see a video. Before going to that video, we have to note some important points, like see the slide. F net equal to delta p by delta t is a universal formula that can be applied for any system, whereas F net equal to ma can be applied for only a system with a constant mass. Okay friends, now let us see some of the examples, problems on F equal to ma. See the slide. How much force is needed to accelerate a 1400 kg car 2 meter per second per second? It means here they have given in the question the mass and the acceleration. Now we have to find the force, how much force is applied on the car. So, first we know that formula. What is that formula? The formula is F equal to ma. F equal to ma. What are the units given in the slide and in that question? M is the 1400 kg and A is the 2 meter per second square. Okay friends. Now what we have to find? We have to find the acceleration of that car, force of that car. Okay. How much force is applied on the car? We need to find here. We have to find here. So F equal to ma, as we know. F equal to, what is the value of m here? 1400 kg and acceleration value is 2 meter per second square. When we multiply this 1400 with 2, then we get F equal to 2800 kg meter per second square. In MKS system, the unit of force is newtons. So, 28,000 newtons. Okay friends, did you get this? Okay, now we have found the value of force here. Does this Newton's second law of motion is useful to calculate the acceleration? Okay, let us see. See here, see on the slide friends. Newton's second law of motion. can be used to calculate the acceleration. How means, let's do another example. Let's solve the problem. Suppose you pull a 10 kg sled so that the net force on the sled is 5 Newton. It means here we all know that sled, it is a vehicle which is used in snow area. So, the force applied on the sled is, how much force is applied on the sled here? 5 Newton, and the mass of the sled is 10 kgs. So, now we have to find the acceleration. To find the acceleration, we have to use this formula. What is that? A equal to F by m, force by mass. So, A equal to, what is the force given in the here? 5 Newton by mass is the 10 kgs. When we cancel it, then we get 0.5 meter per second square. Okay. So, acceleration of that sled is 0.5 meter per second square. Okay friends, like this we can calculate the mass also. Okay. See the slide friends. This is a homework for you. What you are doing, what are you observing here? We are observing a table. In one column we have net force and mass and acceleration. There are the 3 columns and 5 rows. In 2 rows they have given the examples, they have given the answers. But in the 3rd row we have to find the mass. They given the net force and the acceleration. We need to find the mass of the object. So, do you solve this problem? What is the answer there? Yes, you are correct. The answer is 4. When we multiply this mass and acceleration, then we get the force. Yes or no? 4 into 5. 4 5s are 20. And next see here, the net force is 10 and the mass is 5, and here the acceleration is not there. So, we have to find the acceleration. By cancelling this 10 by 5, then we get acceleration. How much? 5 1s are 5 2s are. Here 2 is the acceleration, 2 meter per second square. And next we have to find net force here. They have given mass and acceleration. When we multiply this mass and acceleration 1 into 10, then we get the value 10. It means here the net force applied on the object is 10. Okay friends, I think you understand. Okay. This is the Newton's second law of motion. Now let us see an interesting video on Newton's second law of motion. I think you are eagerly waiting to see this video friends. Okay. Let us see. See the video here. A person applied some force to the ball came into the acceleration. Why? Means the acceleration is depend on the mass of the object and of the object and the force amount of force applied. So friends, in mathematical term, force is the product of mass and acceleration. See there, when he applied some force, the ball accelerates slow, but when he applied more force, then the ball accelerates more. And observe these two here. These are the 2 persons. He is very lean and he is very fat. Here this middleman applied same force on them, but what happened? The small boy, the lean boy was accelerating more, whereas this fat man accelerating slow, because he has more mass than the lean boy. Yes or no? Yes. So friends, we all know that the Newton's second law is depend on the mass. How? According to the mass we need to apply force, then it comes into the acceleration. So this is the video about Newton's second law of motion friends. According to the mass of the object we need to apply force. And next let us see this. Now let us go to the Newton's third law of motion. Before going to the Newton's third law of motion, I will show you one. See here, what is this? This is a duster. I am exerting some force to this duster. Observe here friends, I am exerting some force to the duster. Yes or no?